Welcome to Sairam Tribali YouTube channel. Let us discuss continuation of model 1b average value. Average value is the arithmetic value of all the alternating quantities over one cycle. I mean base is pi, okay, or 2 pi you can take, but average value, so it should be like a symmetrical waveform will be there, right? So that's why you have to take one half cycle. If you took a full half cycle, you will get zero answer, because pi and pi, 2 pi, this cycle get cancel each other, so you will not get the value, you will get zero average. So average must be a half, okay. So this is the equation: average value area under on one cycle divided by base, right? Area of under one cycle half cycle divided by base. See, I is equal to m sin omega t. Just to substitute I d omega t. So I sin omega t 2 I m by pi 0.637, this one, okay. And RMS value, root mean square value. So it's a basic, okay, base in the sense it's a common sense. So if you pass electricity of same resistance, if you pass DC or AC, it will get same amount of heat. I mean, it will give same amount of heat. If suppose if you connect any lamp of resistive load, so if you pass AC or DC, same amount of heat will be produced. So you will get more same value, same output will get it. So H is equal to I square T, H is equal to I square T. So just to substitute over there, and then our RMS value is equal to area under squared curve divided by base. So what happens? So we'll get this V square d omega t, right? And this is a waveform, okay. This is a waveform. See, RMS value you can consider is like this. So you will not get this one, okay, full of this amplitude. In the meters also shows in your electrical measuring devices always RMS value, even though equipments, whatever the equipments, so RMS value only it will show. So I is equal to m sin omega t, everybody knows, and just I'll substitute over here. So area is this one 0 to 2 pi, right? And 1 by 2 pi, 2 pi is the base, just to consider I square d omega t, just to substitute sin square omega t. Sin square omega t you cannot integrate directly. Sin square omega t is equal to 1 minus cos 2 omega t by 2. So and then you'll get it this value 0.707 im. Next, form factor, RMS value by average value, it's a ratio, okay. It's a constant for throughout your engineering branch, engineering life. Peak factor, maximum value by RMS value, not average value, keep it in mind, maximum value by average value, RMS value. So the equations like this: I average is equal to 0.637, IM by root 2, IRMS by average 1.11, 1.414, right? So next there is a phasor representation. Waveform is this one, equation is this one, and phasor, alternate quantities at a particular instant, particular locations, is called as a phasor. So if suppose here there is a conductor present, and so location, so moment of this conductor is called as a phasor. This one is a phasor, okay. This one is a phasor. Alternate quantities particular instant. This is a waveform of this waves. I mean sine wave. So phase difference, difference between any two alternating quantities, current and voltage, or phase difference, omega t. And next we have in phase, current and voltage are in phase with each other. I and V are in phase with each other. V is equal to Vm sin omega t, I is equal to Im sin omega t. So that's why it's called as in phase. The example is resistive load. Keep it in your mind, okay. Resistive load we can consider for in phase. See, two waveforms are said to be in phase when the phase difference between them is zero. So zero difference in the sense crosses current in the same line, right? Here and here and then here. That's why it's in phase. That is 0 point of both the waveform are same. The waveform, phasor and equation representation of sinusoidal quantities which are in phase is as shown. The figure shows that the voltage and current are in phase, right? Next we have a lagging phase. So current lags by voltage at an angle phi. So V is equal to Vm sin omega t, I is equal to Im sin omega t minus phi. Minus phi is the lagging phase, right? So minus phi, and this one is here, current lags by voltage at an angle phi. That's why it's a lagging. And for example, it's an inductor, okay. And next is the leading phase. Current leads by voltage at an angle phi. Capacitor is an example. See here, current leads, voltage lags, right? Voltage lags. See, V is equal to Vm sin omega t, I is equal to Im sin omega t plus phi. So this V is equal to Vm sin omega t is a constant. Keep it in your mind. I is equal to Im sin omega t plus phi, plus for capacitor, minus for inductor. So current leads by voltage at an angle of phi. So in this figure shown, 0 point of the current waveform is before 0 point of the voltage waveform, Hence the current leads by voltage. The waveform phasor equation representation is shown, right? And model 2a is this one. Afterwards we'll discuss.